Hi everyone, we are here for another round of Speed Round with Nidi. She's the DevRel for Pyth network. Thank you very much. How are you?
I'm very good. And as you can see, I am like in the festive attire. So this is Diwali going on in India. Very excited to be here.
I will have the first round, which I'll ask you some questions and you need to answer as fast and as concisely as you can.
Okay.
Can you explain Pyth with a few words without saying the word oracle?
I'll say Pyth is a global pricing layer that provides you the pricing data, not just for crypto, but for equities, commodities, forex, and others. And as the tagline says it, the price of everything everywhere. So I'll put Pyth in that way.
How is Pyth different from traditional data providers or other oracles?
Let's talk about the data source first. So in the case of Pyth, what is happening is we have this 120 plus financial institutions, market makers, topmost exchanges and traders that publish their data directly onto the network. So traditional oracles, they used to follow the push-based model, and Pyth have both push and pull-based. And by default, the Pyth supports the pull-based model. So what happens in push-based model is we have the Oracle network, we have the smart contracts. So in the push-based model, the Oracle network will keep on continuously updating the data onto the smart contracts. So it's the responsibility of the operators that are running the Oracle to update the data. Whereas in the case of a pull-based model, it's the user who is responsible for updating this data on chain. When it comes to Pyth, we have this pull-based model by default because there are certain drawbacks or limitations in the push-based model. If there's a network congestion, the updates are not happening and there could be a case where the Oracle is out of the price. And then for each of the update that the network is doing continuously, the gas is being used. So it's not very gas efficient. The pull-based model allows us to ensure that the price of assets are available from day one. So it's like you deploy an asset and it's available on 100 plus blockchains at once.
How does Wormhole messaging layer enable Pyth to deliver verified real-time data consistently across like hundreds of chains?
That's like a very good question because with Pyth, we have the smart contract, right? We publish it once, and due to Wormhole's cross-messaging platform, we are able to have that contract on multiple chains. So what happens is Pyth is having its own blockchain, which is called PythNet, which is an application-specific blockchain that we have. So Pyth will publish the prices onto this PythNet, and all these updates that are being pushed, they are wrapped and transmitted through Wormhole's messaging protocol. So Wormhole ensures that all these updates arrive consistently and they are verifiable on all the destination chains that we have. So the Pyth will publish it once and Wormhole will ensure that the delivery is done across all the multiple chains. And we have this guardians in Wormhole that plays a very significant role in ensuring and verifying the messages on chain. So with this combination, we are able to achieve the consistent and real-time messaging across all the blockchains.
Yes. Legacy price feeds usually scrape and aggregate data that's often already outdated by the time it's published. How does Pyth change that model?
In traditional oracles or traditional approach, what used to happen is we have this telephone sort of setup. What I mean by that is we have a bunch of nodes. Those nodes will carry the messages and they will perform consensus within themselves. So in our case, since we don't have this sort of setup, which means there is no scraping, and then we have less hops, which results in less latency with Core, the existing product that we have. The price feeds are updated every 400 milliseconds. With Pyth Pro, the upcoming thing that is going to be launched, the price feeds will get updated every 1 millisecond. It all boils down to us getting the data from the first party sources.
So Pyth provides Entropy, which allows developer to generate randomness on chain securely. What is it and how does that work?
Most of these Oracle operators have randomness as one of the key offerings. And with Pyth, we provide randomness via Entropy. Entropy works very different from VRFs. Entropy, it uses a cryptographic technique called commit and reveal protocol. It has two phases in it. The first phase is the commitment phase. So what happens is we have the users like you who wants the randomness, and then we have a provider. So both of these parties, they will generate a random number secretly. They won't reveal it to anybody. Now, at this point, both of them will calculate the hash of the random number that they have generated. And they will commit this hash onto the blockchain. So this is the first stage, which is the commitment phase. So now we have committed the hash onto the blockchain. Now the second phase is the reveal phase. What happens is one of the parties will reveal their random number. Now the other party can verify the random number by hashing it. So I can check the number that you're providing to me is the actual number that you supplied earlier. This allows us to generate the randomness in a secure manner. And this is very cost efficient. It's very straightforward. It's all permissionless.
The US Department of Commerce is publishing economic data on chain through Pyth. So what does this milestone mean for the future of public data transparency?
I personally feel like this is like a very, very big milestone, not just for the Pyth, but for the whole crypto industry. After the government data is going to be stored on a permissionless blockchain. It's like such a big thing for everybody. So now the GDP data is coming on chain, and then it will be expanded later on to the unemployment data and a bunch of stuff that we have from the Bureau of Labor Statistics. So with this, it has clearly shown that government is ready and they're emphasizing on the transparency. They want radical transparency, which is like a very big step for all of us. And we are like really excited about this.
Yeah, and it's a very, very cool use case for on-chain data as well. The ultimate best use case we could have hoped for. All right, so thank you. And now we go into the second round. So the second round is that I give you two options and you need to pick one, okay? So don't overthink it. Ethereum or Bitcoin?
Ethereum.
Layer 1 or layer 2?
Layer 1.
On-chain data or off-chain computation?
On-chain data.
Solidity or Rust?
I am Solidity person, so Solidity.
Let us see your precision. What matters more for Oracle?
With our pool-based model, I think precision, because latency is something that we have already given.
You need to pick one.
This was tough one.
Okay, so we take precision, you said, right?
Yeah.
Dev Connect or ECC?
I'll say Dev Connect.
DevRel or BD?
Of course, DevRel any day.
Holi or Diwali?
Diwali, as this is Diwali week in India. Yeah.
Perfect. Happy Diwali, everyone. Thank you so much, Nidhi. And thank you to the Pyth team for bringing this awesome product and to work with Wormhole, of course.
It was a pleasure. Thank you.
Bye.